This is experiment number 5. Name of the experiment is speed control of 3-phase squirrel cage induction motor by different methods. By different method means here we are going to speed control using variable voltage method. That means we are going to vary the stator input voltage, and along with that we will be doing triple VF control. That means variable voltage, variable frequency control. The theory has already been explained in the theory class. Here we are going to vary voltage and frequency together such that the V by F ratio, voltage to frequency ratio, will always remain constant. Using these two methods, we will be controlling the speed of the squirrel cage induction motor. Here, as it is a squirrel cage induction motor, we cannot insert rotor resistance through slip ring, because slip ring is non-existent in this kind of a motor. So here setup is very simple. We are using a variable AC voltage supply. This is a variac 3-phase supply is given here. Input and output. Output is fed to the stator of the squirrel cage induction motor. Now, as we will be varying voltage, we know that torque is directly proportional to stator voltage square, V1 square. Therefore, if we increase voltage, torque generation will increase, speed will go up. And if we decrease voltage, torque generation will go down and speed will also go down. Now here in variable voltage and variable frequency type, here if we vary voltage and vary frequency by keeping V by F constant, then also speed will get varied. So using these two methods we will be doing the experiment. Here line current and line voltage is going to be measured by this ammeter and voltmeter respectively. Now the experiment will be performed by Hauser.
Because main supply connected to input side of the variac. The output terminal, this is the output terminal of any one of the phases. You can connect three phases are connected like this, and the voltage is this. Such a voltage of output voltage you can check here. And the input current, if you want to measure the input current, then you must connect the ammeter in series with the input. Or if you make the output current, then you can use the outputs. The both that's it. Now here you can see all the connections. And let's start the main switch. Like this. Here we just increasing the voltage. So there's the voltage is 0 now. Here you just put 10 volt. See the current is already increasing and speed also. Now 50 volt. Like this way you can take 10 readings in between 0 to 400, 0 to 1400, 1500. Now for 1491, like this you can take 80, 100. Such a speed at a certain time, speed will remain constant. Now you see the 100 volts like 494. Now it is a voltage, but speed remains constant. Okay? Current moves to 1 ampere. Okay? Stop. Switch on the main supply. Before that, you can see there. This is the main 3-phase supply, and connected to one phase to the I, and then connected to this. Y directly and B directly. So this is the variable frequency, variable voltage microcontroller. Mainly here you can see the frequency. It is the input of variable frequency and variable voltage, and this is the output. Here see 0 to 50 Hz, and output voltage remains, you can see here. Now you just switch on the supply. This is showing stop. Then you just push the dual start. Then it will show 0. Now that means now the microcontroller is ready to run. Now just increasing the frequency like this way. Here 1, frequency is 1. Now gradually you can see that motor is 29 RPM. RPM is just 26 or 29. Is a 0.05 current and the voltage is near about 5 volt. It's just increasing, 1, 2, 3, 4, 5 like this. Now like 5 Hertz frequency, and you can see the voltage is near about 10 volt, 20 volt. and current about 0.1 ampere. Speed 146, like this way, 1, 5, 10, 15, like up to 50. You can take 10 readings, then the graph will show the practically. Now just increasing. Now 10 hertz frequency. So the voltage also increasing, current also increasing, and now the speed also increasing. Now 50. Now 15. Like this way, just increasing the frequency. You can see here that frequency also increasing and the voltage also increasing. Also RPM increasing. Now 32 hertz frequency, near about 140 volts, 961 RPM. Current is near about 0.1. Current, there is no load. No load current is very less. Hertz, near about 185 volts and 0.1 ampere and 1498, 1500 RPM, no load condition. It's near about. Now this is called a proximity sensor, where you can sense, Okay. Now before closing the system, you just decreasing the frequency. Speed also decreasing. Now speed is 0.